Hello everyone, and also IB candidates who are taking chemistry subject. Welcome to my channel, Study with May. Today, I'm going to talk about chemistry paper 1, time zone 1, higher level. If you think this video is helping you a lot to revise or to prepare for the exam or simply investigating whether you understand the content or not, please subscribe my channel and also write down the comment below this video to support me to create other videos. I'm going to cut it to be 2 videos, which is part 1 and part 2. So part 1, which is this video, contains 1 to 20 questions of paper 1, and then part 2 continue for the question number 21 to 40. All right, I'm just going to start with number 1, but if you think that I'm going a bit slow because of I'm just going to make sure, like, you know, those who cannot take it fast, so I hope this also can help them. Okay, let's start from number 1, which contains the most atoms of oxygen. Okay, we're just gonna check which ABCD contains more mole number. Alright, so if we check for A, 64 gram of O2, 64 divided by O2, which is 32, because O, 16, and O2 is going to be 16 times 2, alright, the atomic mass. So it's going to be around 2 mole, alright. So of O2, so atoms of oxygen, not molecule of oxygen, so you need to multiply 2 as well, so it's going to be 4 moles. Okay, so what about B? So 1.2 times 10 to the power 24 for 1 mole is 6.02 times 10 to the power 23, Avogadro's number. 1.2 times 10 to the power 24, it's around 2 mole. How? Because if you divide this to be 2, it's gonna be around 0.6 times 10 to the power 24, which is 6 times 10 to the power 23. Obviously, this is also gonna be around 2 moles. And then what about 64 gram of C3H5O3? Alright, I'm not really sure how you guys are gonna do with math because paper 1, you guys are not using calculator. So 64, if you check the molar mass of C3H5O3 is gonna be around 89. So C3, 12.01 times, let's say 12 times 3 plus H, which is 1 times 5 plus O, which is 16 times 3, so the total will be 89. So oxygen here we have 3. Alright, so it's gonna be times 3. It's around 192 divided by 89, so it's 2 point something moles. Okay, and what about D? 1.2 times 10 to the power 24, also molecule of C3H5O3. As you guys know, this the same like this. Alright, so this is gonna be around 2 moles. So, and here is O3, so 2 times 3, which is 6 moles. Okay, D contain the most atoms of oxygen. Alright, so number 2, a sample of a compound contains approximately 24 gram of C, so C, H, and then O. Alright, so we are trying to find the empirical formula, so simply do this. So 24 gram, and then H is 3 gram, and then oxygen is 1.6 gram. We need to divide with molar mass of C, so it's 12, and then H is 1, and then O is 16, so you guys will get 2, and then this one 3, and then this one 0.1. So we cannot write C2 H2O 0.1 because it doesn't make sense for this one. All right, you guys need to divide this with the smallest number among these three, which is 0.1. So this one also divided by 0.1, and then this one also obviously 0.1. So this is going to be 20, and this one is going to be 30, and this one is going to be 1. So C 20, H30, and then O1, which is A. All right, and then number 3, I'm just going to write it the equations again. So N equals V divided by Vm. So to calculate V, so N times molar volume is needed when 5.8 gram of butane undergoes complete combustion. So when we know 5.8 grams Vm, you know it's 22.7. So what about N? We cannot, obviously there is no oxygen, mole of oxygen here is available, but we can calculate from mole ratio. So, and mole of butane here you can calculate, which is N will be mass 5.8 divided by C4, so 12.01 times 4 plus H, which is 1.01 times 10. What about N of O2? So for mole ratio, we need to, the one that we're looking for will be right here, okay? And then the one that is known, coefficient I mean, so coefficient unknown divided by coefficient known, and then times moles known, which is 0.8 times divided by molar mass of C4H10. So V will be N times Vm. So N, it's 13 divided by 2 times this one, and then times, okay, I'm just gonna write this MR here, and then 5.8, okay, and then also times 22.7, which is Vm. All right, so the question, the answer will be B. Continue to number 4. So this is a little bit tricky for you. Okay, so if we see here, all right, what is the relative molecular mass of bromine? So as you guys know, bromine, diatomic molecule. So if you look at on the periodic table, of course, AR of bromine is around 79 point something, so let's say 80. So obviously you guys will see it here and then think the answer is D, right? It's D. However, bromine, it's Br2, so it's gonna be around 106D. So it's not this one, and obviously it's not this one. And then yeah, if 79 is here, and also we cannot do this one, it's the correct answer. So it's gonna be this one, which is Br2. All right, it's gonna be 158 right here times this, gonna be around 52. You need to divide by the sum of the relatives intensities. It's obviously A. All right, so what about number 5? The answer will be C, because A is a hybrid, and then orbital of this one is S, and then this Y is pi bond. So the answer is C. And then 6, this is also a very interesting question. This is the trend of ionization energy across a period. So there's gonna be a group 1, okay, and then there's gonna be a group 2, and then this one is group 3. Which factor explains why element X has a higher first ionization energy than element Y? So we're looking only at this 2. Okay, so ionization of Y is lower compared to X. Obviously, group 3 is the last electron is easier, so it's easier for you to lose the last electron in group 3 compared to group 2. So you need to find something that really explain why ionization energy in Y of the element Y is lower compared to element X. Element Y loses an electron from a different sub-level. All right, so because as you guys know, so group 2, for example, group 2, it's BE, okay, BE, which is 4, and then for group 3 or 13, it's B, which is 5. So we'll see 1s2, 2s2, and then 2p, 2s2, and then this one 1s2, 2s2, and then also 2p1. So this one is already sub level, and then you guys know that this is for more the electron in the outermost shell is further away. This one is further away from the nucleus, so makes it easier to ionize, correct? What about element Y has a smaller atomic radius? It is correct. B has smaller ionic atomic radius compared to BE, right? Because of higher nuclear charge, and then also the attraction of protons is higher compared to BE. This one is correct, but the same case with also D. Element Y has greater nuclear charge. Yeah, this one is +3 and this one is +2. Why not B? B and D, they're not wrong, but they don't really explain why ionization is lower. B and D is only explaining why it's difficult to ionize, so holding electron in the outer shells more tightly. So they don't really, so B and D do not really explain why the ionization energy is lower, only explaining why it's difficult to ionize. So obviously the answer will be A. So let's go to number 7. No need to write down the electron configuration 1s1, 2s2, 1s2, 2s2, things like that. So just, you know, argon atomic number is 18, so number of electron will be also 18. So we'll see Br here, protons number very high, it's more than 18, so this is not the answer. And then Ca is 20 because of 2 plus, the number of electron will be 18. And then Al, it's 13, so number of electron is 3 plus, so it's 10, not this one. And then Si is 14, all right, because of +4, electron will be 10. So the answer will be B. And number 8, which trend is correct going down group 1? So melting point increases, okay, and group 1 melting point decreases, so not increases, because the atomic radius radii increases, so easy to lose the electron, so you need low energy, therefore melting point decreases, okay. And then what about reactivity? Decreases. And as you guys know, francium is more reactive compared to lithium or sodium, because again, easy to lose the energy, so more readily to react with other element. And this one will be increases, okay, down a group. And then first ionization energy increases. Atomic radius, of course, First ionization of an energy increases. Atomic radius of group 1 down a group increases. So you don't need that a lot of energy to lose the electron. So first ionization energy decreases because atomic radius increases. So atomic radius, if it's bigger compared to smaller atomic radius, okay, so this one will be easier to lose. So ionization energy is required to lose this electron lower compared to this one. So down a group, ionization energy decreases. So obviously the answer will be D. All right, what is the overall charge of X of the chromium 3 compound? So if it's 3, it means Cr plus 3, okay? So if it's Cu 2, it means Cu plus 2. All right, if it's Cu 1, it means Cu plus 1. So let me just draw it again. Cr H2O for Cl2. Okay, so this Cl, the charge, okay, the ligand here, and then H2O also ligand here, and Cl, you know, the charge of the ligand is -1, and then H2O ligand, it's 0, so 0 times 4 is also going to be 0. So now, and you guys know Cr is plus 3, so plus 3 plus 0 plus -1, it's plus 1. So the answer is B. All right, and number 10, this is also a straightforward question. Which compounds contains both ionic and covalent bonds? You guys no need to check MgO. Oh, MgO, this one is metal and then this is non-metal, so of course it's ionic only. But the key point here, a compounds that contains both ionic and covalent bonds, the compound should be, or the compound should contains polyatomic ion. For example, like NO3 minus nitrate, SO4 2 minus, or PO4 3 minus, or CO3 2 minus, things like that, okay? OH minus. So in this case, it's gonna be NaOH. If we want to break it down, NaOH, this is the polyatomic ion, OH, so it's gonna be Na plus OH minus. So this two, between Na plus and OH minus, ionic bond, and between O and H is covalent bond. Let's go to number 11. Let's see number 11. Okay, so which substance is most likely to be ionic? Ionic compound, as you know, able to conduct electricity. So electricity will be high, but the thing is here it's solid, okay? Ionic compound able to conduct electricity if it's only melted. So high, of course, that's not the case here. What about melting point? Melting point of ionic compound is high, okay? Is high, and then because of hexane is an organic solvent, so the solubility of ionic compound will be low in hexane because hexane is non-polar. Polar does not dissolve in non-polar, so obviously the solubility will be low. So the answer will be D. Which contains delocalized electron? Now we're just gonna check CO3 2 minus. So O, C, and then O here, 2 minus, okay? All right, contains the delocalized electron because it has double bond here. And then A is not, obviously it's not the answer. And then we'll see now C6H5OH. C6H5OH, okay, this, and also OH. So because of double bond here, double bond here, double bond here, because this can move right here, and then this can move right here, and then this can move right here. So 1 also, 3 also, 3. And then what about CH3COO? This is also contains the delocalized electron. So the answer will be D. Okay, so now number 13. Which series are all carbon atoms sp2 hybridized? Let's just, okay, sp2, it means has 3 domains, because S and then P and then P. So it has 3 domains. So if it's sp, has 2 domains. Okay, sp3 has 4 domains. 4 domains, 3 domains, 2 domains here. For example, when you try to predict the name and then also angle of a compound. So if it's 4 domains, for example, tetrahedral. Let's see for C2H2. So you can draw C2H2. C has 2 domain. It means 2 sides right here and then also right here. So this one is sp. What about C2H4? Okay, so C2H4, 1, 2, 3. So it's sp2. And then C2H6. Okay, so 1, 2, 3, 4. So it's sp3. So it means this one. Okay, this one. And number 14. Here is gram, 5 gram, and this one is kilogram, and then kilojoule. Right, look, there is no need to do times 10 to the power negative 3, because of his, here is a gram and then here is kilogram, because it's gonna be 1 kilogram requires 4.18 kilojoule. So if it's 1 gram, require 4.18 joules. So there's no need to convert it to 10 to the power negative 3. So Q equals to MC delta T, and delta T, I know it should be in Kelvin, but then when you just try to check the difference between 10 and then 18 is going to be 8. So mass will be 5, C will be 4.18, and then delta T will be 8. So the answer will be A. Okay, we'll do number 15 now. To calculate enthalpy combustions of this will be enthalpy combustions of reactants minus enthalpy of products. So as you guys know, O2, oxygen, is not combustible, so there is no enthalpy combustions of oxygen. So it means that we don't need to include this one, all right, in the calculation. So delta H will be reactant minus product. So it will be, don't forget, it has 2 here, and this one also has 2 here. Okay, so 2 times graphite, which is C, negative 394, minus 2 times minus 283. Okay, why 2? Because of CO also has 2 here. So 2 times negative 394, it becomes plus because of negative here and then negative here. So 2 times 283. So the answer will be D. Let's go for number 16. You guys see it here. All right, so the temperature increases. So obviously it's exothermic. And if it's the T, okay, increases. And then delta G here, it's more negative. Okay, so the reaction here, spontaneous. Let's see for A, exothermic. Okay, it's exothermic reaction, and then the T also increases. So equilibrium will shift to the left. K will decrease. Okay, delta G becomes more positive. But here delta G is negative. So A is not the answer. And then what about B? Okay, B below 300K. Alright, but then it mentioned more spontaneous. Obviously, if the temperature is low, delta G becomes more positive. And if it's delta G becomes more positive, it's obviously cannot be spontaneous. It should be non-spontaneous. So B also cannot be the answer. And then for C, entropy is higher in the products than in the reactants. So if it's delta G, it's more negative. Of course, delta S will be, entropy will be positive. As you know, temperature increases, so disorder will be increases, of course, because of temperature increases. So particle moves very fast, and disorder increases, of course, entropy will increase and positive. So entropy is higher. C is correct. Kc decreases as temperature increases. If Kc decreases, delta G will be more positive. So, but here delta G is negative. So it means obviously D is incorrect. So question number 17. Which substance has the highest lattice enthalpy? The ion that has high charge, right? Nuclear charge. So which one that has higher nuclear charge? Between K and Ca. So Ca. So K, not. So it's going to be between B and then D. And also small radius. Okay, which one that has small radius? Cl and then F. So sorry, so A is not anymore, so it's now between Cl and then F. F has smaller atomic radius, so the answer will be D. Let's continue. Number 18. Graph 1 shows the mass change when marble chips are added to excess hydrochloric acid in an open beaker. Which changes would produce curve 2? Look, here is the start. Okay, so doubling their mass. If we just change the chips becomes powder, not gonna start from here, it's still gonna start from here. Okay, if it's doubling the acid concentration, it would also double the mass. No, because of it's only concentration. If we double the volume, all the time will be slower. At the same time, it will only increase moles of HCl. So we won't expect the end of the curve 2 will be right here. And HCl is already in excess, so there is no point to double the volume of hydrochloric acid. So the answer will be B. 19. It's Maxwell-Boltzmann. Okay. On the following Maxwell-Boltzmann distribution, which letter represents activation's energy? Here it already has more energy. And this part has more kinetic energy because way right here. Alright, so it's obviously B. And number 20. Okay, this question also quite tricky. Nothing is written like which one is fast, which one is slow. Obviously, you can only check from the step which is slow. We try one of these two. If step 1 is being slow, so obviously rate will be Ka square. So we check this one. All right, what if now this one becomes slow? We check here, forms B, and then this one also B. So it means B is the intermediate product. And as you guys know, intermediate product will not be in the equation of rate of reaction. And we see here is B, and we see here is B. So this one obviously is not. What about this one? Okay, so if let's say step 2 is slow, so rate of reaction will be K times A square and also C, because it's only reactant, but this one is only A, so the answer will be C. Alright guys, so for question 21 to question 40, I will continue to explain in the video part 2. So if you guys think that this video really helps you a lot to understand, or for you to revise, or for your revision, so please don't forget to subscribe my channel and also write the comment below. I will also make the second part of my video, and then I'm going also to explain other chemistry paper, time zone, or also different year. And I hope this video again can help you guys to study and prepare for the exam. And see ya.